Yes, right now we completed the first theorem. I observed many students of school level, whenever they are asked to prove the theorem, they try to by heart it. Never do this. You have understood this particular theorem, you have noted it once, take a rough paper, and whatever I discussed, you just try to recall, and minimum 3 times you have to reproduce on the rough. Then you will be perfect with it. And you have to hold the logic behind it, diagram, how the diagram can be drawn. And by looking at the statement, you must understand what is the given and what is asked in it. Asked is written as to prove, then if at all, then we have to plan the proof of it. That the planning of the proof is very important and it should be logical. Then after writing every statement, you must go on giving the reasons. Therefore, geometrical theorems can be proved only by systematic learning. Okay, with this background, let us see the second theorem. What is the statement of the theorem, dear students? The lengths of tangent from external point to a circle are equal. Only this much will be given in your examination. And first of all, you must understand the theorem. What is the theorem? And in the introduction, I told you that how many tangents you can draw from an external point to a circle. Suppose that this particular P is an external point. From an external point, how many tangents you can draw to a circle? Yes, exactly. You can draw maximum how many tangents? 2 tangents can be drawn. Let us draw the circle, and you take compass and draw the circle. Don't just look at it, open your pen and paper. You have the classwork book. Let me draw 2 tangents. One is PQ, and don't use a pen in your examination. Use a geometry box. O be the center of the circle. Let us call this one as PQ, this one as PR. 2 tangents can be drawn from an external point to a circle. This is what is given. The relevant diagram is drawn here. Relevant diagram is drawn here. First of all, we have to write what is data. First is the diagram. Then whatever you have written in the whatever diagram you have drawn, based on that you have to write the data. What is the data? O is the center of the circle. O is the center of the circle. Center of the circle. Yes. PQ and P is an external point. P is an external point. External point. PQ and PR are tangents. PQ and PR are tangents. Okay. Yes. First work is over, diagram is over. First step is in proving the proof. Theorem is diagram. We have drawn it. Data completed. Now, what you have to write is to prove. What is to be proved? Read the statement. The length of the tangent from an external point to a circle are equal. Means what? You have to prove that PQ, tangent PQ is equal to tangent PR. PQ is equal to PR. Now comes the part of the proof. Before you prove, you have to plan, very important, or understand the plan. Let me explain you. See, to prove PQ and PR, we must create a situation so that we can prove this. How? And if I take, already you studied triangles to prove, we are using some criteria for congruences. You studied SAS, SSS. To create that situation, I am making a small construction here. See, if you join the radii OR and OQ, join OP. Why I am doing this? By doing this, I will get 2 triangles. One is PR, OPR, another one is OPQ. 2 triangles, and already you studied from the first theorem that this is right angle and this is right angle. Try to understand my plan. Our aim is to prove that PQ is equal to PR. What we are going to do now? If I join this OP, observe there are 2 right angle triangles because this angle is 90 degree, this angle 90 degree. You can prove it by using RHS, right-handed hypotenuse side. How? This OQ is equal to OR. Then OP is equal to OP is common. Right? When a hypotenuse, this is hypotenuse, this is the base. When a hypotenuse and base, two sides are equal, then these two triangles are congruent. By corresponding parts of the congruent triangle rule, CPCT, PQ will be equal to PR. That is my plan. Let us execute this plan in the form of the proof. Let us write the construction. What is construction here? Make the construction. I hope you understood the plan. The join OQ, OR radii and join OP. Now the situation is ready for the proof. Proof is that you must go on writing. Let me rub this part, which is the data. I think you have noted it already. Proof of it. The proof is in a triangle OPQ and a triangle OPR. What do you get here? OP is equal to OP. What is OP is equal to OP? You have to write a reason here. Common. Reason is common. And OQ is equal to OR. What is the reason? Reason is radii of the same circle. Radii of the same circle. Radii of the same circle. These two conditions are sufficient according to RHS. Therefore, a triangle OPQ is congruent to triangle OPR by right-handed hypotenuse sides. Therefore, you can simply write it as PQ is equal to PR. What is the reason? CPCT, you know what is CPCT? Corresponding parts of the congruent triangles. You can say that PQ is equal to PR. What is our TPT? To prove that PQ is equal to PR, hence the proof of it. Very, very simple theorem, hence the proof of it. Yes, my dear student, theory part is completed. This much is sufficient in this particular small chapter, circles. How the questions will appear in the examination, that we will discuss after this. Please note down this theorem, repeat it 3 times, show me in the next class.